To illustrate the importance of statistical tests and crosstabs, I have here a cross-tabulation that tests the hypothesis that individuals with higher levels of education will be more pro-environment than those with less education. This is the NES 2012 data set, and I've tested the hypothesis using DEM underscore EDUC 3, which is 3 categories of education, and EnvirJobs 3, which is a measure of environmental attitudes. Response has to pick the environment or jobs. So here we have the high school or less row, some college, college plus. Let's test the hypothesis by examining the pro-environment row here. 38.1% of those with less than high school, 37.8% of those with some college, and 41.3% of those with the highest level of education. So we can see, we're trying to interpret this relationship. One might argue, I suppose, that sure enough, as education goes up, the pro-environment response does increase. It's rather weak. It increases by 3 percentage points across the range here. So we might be tempted to say the hypothesis is confirmed. But let's have another look at it. The way a chi-square looks at a relationship or a crosstab like this is to first look at the distribution of the dependent variable down the total column here. 39.1% are pro-environment, 36.0% are in the middle position, and then 25.0% are in the jobs position. And chi-square asks, looking at this 39.1, for example, could departures from this 39.1, that is, this departure, 38.1 in this cell, 37.8 in this cell, and 41.3 in this cell, could these departures from this expected 39.1 be explained by random sampling error? So chi-square applies this idea to a cross-tabulation, looking at this cell, for example, 36.0, and asking, could each of these departures from this expected value of 36% be explained by random sampling error? All right, let's get the analysis. I'm going to click Analyze, Descriptive Statistics, Crosstabs. Everything's set up from the previous analysis here. In this case, however, I'm going to click Statistics, and up here I'm going to ask for chi-square, the chi-square test. And over here I'm going to request Somers D. Somers D is in this ordinal window over here. This is the measure of association that's preferred if you have ordinal independent and dependent variables. I'm going to click Continue and OK. SPSS runs the crosstab again, and it's given us a couple other tables here, chi-square tests and directional measures. Let's look first at the chi-square test output. As usual, SPSS gives us a lot of information. We only need to focus on the top row here, Pearson chi-square. There's a calculated value of chi-square. The null hypothesis says in the null's world, these values should all be 0. Well, we got 7.449. So the null hypothesis is contradicted to some degree, it would appear, but to what degree? Look at this p-value here. This is the significance value for the chi-square statistic, 0.114. Interpretation. If the null hypothesis is correct, and the table we looked at up here could have been produced by random sampling error when we took the sample, then we would indeed get the observed values in that table about 11.4% of the time, 0.114. Since this p-value exceeds 0.05, we would not reject the null hypothesis. We would say, yeah, there's too high of a probability that random sampling error produced the data that we see. So in this case, we would not reject the null hypothesis. We knew the relationship was pretty weak. Let's look down here at directional measures. We asked for Somers D. SPSS gives us 3 Somers D, a symmetric one, a Somers D when the dependent variable is considered the dependent, EnvirJobs underscore 3, and then when education, the independent variable, is considered dependent, because SPSS doesn't know which variables are which. We'll always pick the row that names our dependent variable. So in this case, it's going to be the center row. This value, minus 0.029, what does this mean? Well, it's negative. It's a negative sign because increasing values of the independent, that is, increasing values to go up from low education to high education, are weakly associated with declining values of the dependent, since the environment has a lower code than jobs. But for interpreting the Somers D, you can ignore the sign, and here's what it means. Compared to how well we can predict environmental attitudes by not knowing individuals' levels of education, we can improve our prediction by about 2.9% by knowing level of education. So it's a very weak, very weak strength of a relationship in this case.